Last lesson in Unit 1 here, it's all about vectors. Vectors! First of all, a vector, if you've taken physics, hopefully you're familiar with vector. It is a quantity that has a direction as well as a magnitude. So direction is which way it's pointing, magnitude is how big it is. The way we write vectors, we usually write them in their component form. It looks like this. We've got kind of a less than symbol, greater than symbol on the outsides to show that it's a vector. And we write how much the x value changes, comma, how much the y value changes. To find the magnitude of a vector, really what we're doing is we're using the Pythagorean theorem. So we're using like x a squared plus b squared equals c squared, and then to solve for c, you take the square root. To show that we have the magnitude of a vector, magnitude again is how big it is. You put two vertical lines on each side to show that it's the magnitude of the vector. So we're going to square the change in x, square the change in y, add them up, and take the square root. And that should give us the size of a vector. So example 1 here gives us a vector. Vector, notice it has a size, but then it also has a direction. It starts at that point, goes up to this point. It wants both the component form and the magnitude. So to get the component form, the vector is equal to the change in x. So I started here, I'm ending here. So to go from there to there, my change in x is I go left 2, negative 2, and up 1, 2, 3, 4, 5, 6. That is the component form of the vector. The magnitude of the vector is equal to the square root of the change in x squared plus the change in y squared. So the magnitude is 2 root 10. Next question here wants to know, is vector addition commutative? So to add vectors, what we do is we take the vector, we add them tip to tail. So if I have this vector, it starts here and it ends there. So if I add that vector first, and then I add this vector, and then I add this vector, notice my resultant, my answer, would be we start here and we end here. So this arrow, the red arrow here, is the answer, the sum of those 3 vectors, whatever that magnitude and direction is. Question asks, is vector addition commutative? So could I add them in a different order and get the same thing? So if I add this one first, and then I add this one, and then I add this one, do I get the same vector? Notice if I add them tip to tail, notice I get exactly the same vector. And it doesn't matter which order you add them in. You could add them in any order you want. This one, and then this one, and then that one. And no matter which order we add them in, we're going to get that same vector right there. So vector addition, yes, it is commutative. Doesn't matter which order you add the vectors in. In order to add them up, without actually drawing them all out, what we're going to do is we are going to add up their components. So find the sum of the delta x's, find the sum of the delta y's. So you're simply just going to add their components up. So example 2, it defines vector u as 4, negative 3. Vector v is 2, 5. It wants us to take twice u and subtract 4v from that. So twice u would be 8, negative 6. If we take 4 times v, I get 820. And then to subtract the vectors, you are going to subtract the delta x's. We're going to do 8 minus 8, negative 6 minus 20. Easy enough. A unit vector is a vector that is in the same direction as the given vector, but its magnitude is only 1. So if I have a vector that looks like that, if we take that vector and then shrink it down so its magnitude is only 1, that would be its unit vector. Or if its magnitude was less than 1 to begin with, you would make it bigger until its magnitude is 1. Oops. So this one asks us for the unit vector of the vector negative 5, 12. How many times have I said vector already in this video? Find the unit vector of negative 5, 12. So to do that, we need to find the magnitude. So the magnitude of this vector is going to be the square root of negative 5 squared plus 12 squared. This vector has a magnitude of 13. And all you're going to do is divide the components by the magnitude. And that's it. That is in the same direction as negative 5, 12. But if we were to find the magnitude of this, so we've got 5, negative 5 over 13 squared plus 12 over 13 squared and then take the square root. Notice even before I take the square root, if I take the square root of 1, this does indeed have a magnitude of 1. Example 4. Find the vector that has a magnitude of 6 that is in the same direction as the vector negative 4, 6. So we're going to start by finding the unit vector. Get the unit vector. Again, we use the Pythagorean theorem here, square root of a squared plus b squared. What is that, 52? 4 times 13. So the magnitude of this vector, this given vector, is 2 root 13. So we're going to divide each component by 2 root 13, and that'll give me the unit vector. So I'm dividing negative 4 by 2 root 13. Divide 6 by 2 root 13. So this vector is in the same direction as the one that we want, but it is the unit vector. It has a magnitude of 1. So if I want the magnitude to be 6, just multiply everything by 6. And if you're feeling ambitious, you can rationalize. I'm going to leave it like that because I'm lazy. And then the last thing we need to talk about is the dot product of 2 vectors. The dot product of 2 vectors. First of all, it results in a scalar. A scalar is just something that has a magnitude but does not have a direction. And the way we do it, if we have vector u is defined as AB, vector v is defined as CD, what we do is we multiply the x components of the vector together, we multiply the y components of the vector together, and then we add them up. The dot product of u times v is equal to AC plus BD. Again, it's just it's a scalar, so it has a magnitude. We don't need to worry about what direction it is. So it's just going to be a number. It's not going to be a vector. It's not going to look like this. So we're just going to have a number here. So this one wants, it gives us u and v. It wants us to take the dot product of u times u and then multiply that by vector v. So let's start with u times u, the dot product of u and itself. So we would have 4 times 4 plus negative 5 times negative 5. Basically, we've got 4 negative 5, and then this one's 4 negative 5 because it's u times. So AC is going to be 16, BD is going to be 25. So the dot product of u times itself is 41, and I want to multiply that by v. Now I have a scalar times a vector. That's going to give me a vector. All we need to do is take vector v and multiply it by 41. And whatever 41 times 6 is, 246. And that's it. That's vectors.